Good morning. This is your Stat Sensei, Mr. Spensei, and this is the Death Packet for chi-squared and regression, and these are going to be problems 71 through 80 for regression. So a company trains its employees with instructional videos and claims that the amount of time and hours spent on training is linear related to increase productivity. The company selects a random sample of 5 employees. That's going to be important. So we know our sample size is 5. The data we use to create the computer output for a least squares linear regression shown in the table. Awesome. Which of the following is the test statistic and the degrees of freedom? Okay, so first off, not sure that I buy into this. This looks like this number right here, I believe is wrong. But let's go ahead and talk about the test statistic. Well, the test statistic is basically going to be um, T equals B over S or SE. So our slope over our standard error. Well, this is my y-intercept, so this is my slope, okay, my slope row. So my slope is 0.8. So 0.8 divided by 0.3464 should give me t. So let's see what that does. 0.8 divided by 0.3464. And I get a t statistic of 2.31. Well, or 2.309. So knocks it down, knocks these out, and we're down to A and B. Now, here we have a sample size. Well, degrees of freedom for regression is n minus 2, so 5 minus 2 equals 3. And in this case, our best choice is that is B. But please keep in mind that it's slope over standard error of the slope, that T equals slope over SE of the slope, standard error of the slope. That's an important formula to keep in mind. All right, a business school is conducting a study to investigate whether a student's scores on a placement test can be used to predict a student's starting salaries. Based on a random sample of 200 graduates of the business school, a 98% confidence interval for the slope of the linear regression line relating to the placement scores with a starting salary is calculated to be 315 to 336. All right. Assume the conditions for inferences were met. Which of the following is a correct interpretation of the confidence interval? So let's go back and look at this. Um, whether student scores on a placement test can be used to predict starting salaries. So we have a positive relationship. So if we have a positive relationship, we're going to assume that as scores go up, salary goes up. And the reason we know we have a positive relationship is both of those are positive. All right. So when we look at that, there's a 98% probability. As soon as we had the word probability, I was out. That's not going to be it. 98% of the time, don't like that either because it's not 98% of the time. We're just 98% confident that it's contained in there. We are 98% confident, like that word, that a 10-point increase in a placement score will result in a predicted starting salary of 3,150 to 3,360. And you're like, wait a second, that's not what it had. And it's like, oh, well, let's go back to this. It talked about a to investigate whether students score on a placement. So if we had a 1 point increase, we'd have a 315. But since we have a 10-point increase, we have to multiply by 10. So 315 times 10. All right. And we are 98% confident that 10-point increase. So we multiplied the 315 times 10 and the 336 times 10 because of the 10-point increase will result in a predicted increase. All right. That's what we're predicting. We don't know that that's going to happen. And I like that word that it says we're predicting um, the predicting. Let's say this is a good possibility. The next one, we are 98% confident, sounds good, that predicted starting salaries will be between 315 and 336. No, we're only confident about that if there was a 10-point increase. All right. And this one would actually not be a 10-point increase. This would have to be a 100-point increase. So that's not right. Okay. And then the last one, we're not confident that it's making predictions between it. We're confident that the mean salary increase is going to be lie within this. All right. The average predicted will be within that. All right, the next one. A sociologist recorded the number of contacts entered into a cell phone and the number of texts sent in a week for 20 cell phone users. The resulting data were used to conduct a hypothesis test to investigate whether there is a linear relationship between the number of contacts and the number of texts. What are the correct hypotheses for the test? Well, first off, we need beta. All right, so this is wrong. All right, that will never be the lowercase. That is from the sample. We need the population. The next thing is we need equal signs for our um, null hypothesis. So the null has to be equal. That gets rid of D. So now we have a couple that look like they're possible. And the only thing is that they didn't indicate any direction. If they don't indicate any direction, they ask whether there is a relationship, which means it could be greater than, it could be less than. So we have to go with not equal to for our alternative. So unless they specify increase or decrease, we have to go with not equal to. So our best answer choice for 73 is E. Number 74. Baseball statisticians study how often triples a certain event in a baseball game occurred in professional games played between 1947 and 2017. A 98% confidence interval to estimate the slope of the linear regression line relating the year X and the mean number of triples per game Y yielded this. All right. So basically, we're going to say, okay, numbers of trips, number of triples over year. All right, well, I notice that this is negative, which means as year increases, the number of triples decreases. All right. So a check shows that the conditions for inference for the slope of the regression or lines are met based on the confidence interval. Which of the following claims is supported? The mean number of triples is between this. No, we're not talking about the mean number. We're talking about the relationship between triples and years, and it's showing that it's decreasing. The number of triples has increased. No, we said as the years increased, the number of triples decreased. C, there's no linear relationship. No, we know that there's a linear relationship, and the reason we know there's a linear relationship is 0 is not in the interval. If 0 is in the interval, we could say there's no linear relationship, but it's not. So there is a linear relationship because 0 is not contained. There is a negative linear relationship, obviously, between the mean number of triples per game and year. That looks pretty good to me. Let's read the next one. A conclusion cannot be made. No, we can make a conclusion. There's definitely, so D is our 74 for D is our best answer. All right, number 75. A researcher recorded the number of emails received in a month and the number of online purchases made during that month for 50 people with an online presence. The resulting data were used to conduct a hypothesis test to investigate whether the slope of the population regression line related to the number of emails to the number of online purchases is positive. All right. So this is different. So basically, if we're looking at positive, the slope of the regression line relating the number of emails to the number of online purchases is positive. And so what they're saying, hey, if it's positive, remember if you had a number line, it'd be -1, -2, 0, 1, 2. So positive is up here, so we're looking for a greater than for our alternative. Well, right away, I know I can get rid of this one because it'll never be, that's for the sample, and we need beta for the population. We also need equals for our null. So beta has to be an equal for the null. So that gets rid of this one. All right, we're looking for a greater than, and the one with greater than is B. So 75 is B. 76. A researcher is interested in the relationship between time spent browsing items in an online store and the total amount purchased from the store. The researcher selects a random sample of visitors to the online store and records the time spent browsing the total amount of their purchases. The researcher will conduct a t-test for the slope of a regression line where time spent browsing is the explanatory variable. All right. So we're getting a t-test, and our slope is going to be B equals the explanatory variable is time spent browsing. So I'm going to put time down here. And the number of purchase is the response. Which of the following would be an indication that the normality condition has been met? Okay, a sample size that is less than 30. That doesn't have anything to do with it. No, we don't want sample sizes less than 30. We want sample sizes of greater than 30. And so that's not it. We'd have to be greater than 30. A histogram of the residuals that is centered on zero and strongly right skewed. No, our residuals need to be normally distributed. We can't have strongly right skewed. So don't like that. A dot plot of the residuals that is centered on zero, unimodal, and symmetric. Kind of liking C so far for this one. Let's keep going. A box plot of the residuals that is centered at 100. No, we're not centered at 100. We're centered at 0. A scatter plot where total amount of purchase is the explanatory variable. No, we're not looking for a scatter plot. We're looking for the residuals. All right, so we needed to be looking for the residuals, and the best answer choice for this is C because it's centered at 0, unimodal, and symmetric. All right. And a matter of fact, we would be happy with symmetric and no outliers. Okay, moving on to number 77. Anaga, and I have no idea if I pronounced it right, is interested in buying a new Model X car and wants to gather information about the selling price of the car is related to the year of the model. She randomly selects 24 used Model X cars for sale. For each used car, she records the car's selling price in dollars and age in years. She computes a 96% confidence interval to estimate the slope of the regression line, the age of a used Model X car to its selling price. The resulting confidence interval is given as negative 5,556 to negative 3,157. This should all be on one line, but both of those are negative values. Assume the conditions for inference on the slope of the regression line are met. Which of the following is the correct interpretation of the confidence interval? So what we have here is we have negative. So basically, as age increased, as age went up, price went down. All right, so that's what we're looking at. All right. So we are 96% confident the Model X will have a predicted decrease in selling price between this. Don't like that because it didn't mention the years. All right. So we have to mention the years at that point because we have to say what the relationship is. 96% of the time. No, it's not 96% of the time. That's wrong. All right. 96% of samples. Nope, we're not worried about the samples. So that's not going to be it. We're talking about the population. We are 96% confident. Hey, there's that word we like. That any sample of 20. No, we're not worried about the sample. We're worried about the population. We are 96% confident that a 1-year increase in the age of the model car will result in a predicted decrease in selling price of that. Age went up, price went down. That's what we're looking for. And the increase in age will result in a predicted decrease in selling price. I like that one. Okay. Number 78. A pharmaceutical company is examining the relationship between dosage of a new pain relief medication and the time it takes for patients to experience pain relief from headache. Various dosage range from 200 to 1200 milligrams in 100 milligram increments. So they went 200, some got 300, some got 400, etc. And this was issued to 41 randomly selected patients, and the time until relief was measured in minutes. Okay. A check of the conditions necessary for inference for the slope of the regression line shows they are met. A 95% confidence interval for the slope of the regression line relating dosage to time until relief is negative. All right. Well, that means as dosage increase, as dosage went up, the time to pain relief went down. Based on the confidence interval, which of the following is supported? All right. A 100 milligram increase in dosage results in a decrease in the time until pain relief by more than 2 minutes on average. You know, that's actually looking pretty good because we know that's 4 minutes, that's 2 minutes. So we know that it's more than 2 minutes because it's 2.27 minutes. So it's like, hey, if we increase it by 100 milligrams, we're expecting a 2.27. And by the way, they said they 100 milligram increments. That's where that came from. Results in a 2.27 decrease. So I like this one. 100 milligram increase results in a decrease in the time until relief by more than 4 minutes. No, it's not by more than 4 minutes. It could be as much as 4 minutes, but it's not. We can just say that it's more than 2 minutes. We can't say that it's more than four because it's somewhere between there. So it could be as low as 2 minutes. There is not a linear relationship. No, we know it's not. There is a linear relationship because zero is not contained. 100 milligram increase in dosage results in an increase. No, we said dosage results in a decrease. 100 milligram increase in dosage results in an increase. No, that's wrong because we already said it's a decrease. As dosage went up, time went down. So our best answer choice for 78 is A. 79. A random sample of 15 college soccer players were selected to investigate the relationship between heart rate and maximal oxygen uptake. All right. The heart rate and maximal oxygen uptake were recorded for each player during a training session. A regression analysis of the data was conducted where heart rate is the explanatory variable. All right. So we have a slope, and we're going to go heart rate in the denominator. And oxygen uptake is the response. If a 95% confidence interval is constructed for the slope of the population regression line, which of the following is a condition that must be checked? The confidence interval is not biased. That's not a condition. All right. That's just we don't take biased samples. We take a random sample, so that's not going to be it. That's not a condition we check. The correlation between heart rate and maximal oxygen uptake is not zero. Correlation coefficient, not a condition. The point X average, Y average falls on the regression line. It does every single time, not a condition. All right. That's just saying the mean of the X's and the mean of the Y's falls on the line. And that's like, yeah, that's the predicted values. Yes, it will. The true relationship between heart rate and maximal oxygen uptake is linear. Ooh, we definitely need to look at that. That looks pretty good because that is one of our things. We always check a scatter plot to see if linearity exists. The slope is not equal to zero. No, we actually test that for a hypothesis test. So that's not it. Our best answer choice for this is D. We're looking for, there has to be a linear relationship between your X and Y values. So there has to be a linear relationship between oxygen and heart rate. All right, moving on to number 80. A seafood sales manager collected data on the maximal daily temperature and the daily revenue from salmon sales. R using sales receipts for 30 days selected at random. Okay, so salmon sales is R. All right, using the data, the manager constructs a regression analysis and found the least squares of the regression line to be R, salmon sales equals 126 plus 2.37 T, where T was our temperature. All right. A hypothesis test was conducted to investigate whether there's a linear relationship between maximum daily temperature and the daily revenue from salmon sales. The standard error for the slope is 0.65. Okay. Assuming the conditions for inference has been met, which of the following is closest to the value of the test statistic for the hypothesis test? All right. Well, T equals slope over SE of slope. Well, our slope is 2.37. So T equals 2.37. This is T for test statistic divided by our standard error of 0.65. Another way to say T equals B over SB. Sample slope divided by standard error of the slope. All right. So let's divide that out and hope I have the right answer. 2.37 divided by 0.65. And I end up getting 3.646. 3.646. So closest answer to that for 80 is D. I hope that helps, and I look forward to seeing you on the next one. Thank you.